The solenoid switch valve directs fluid to the low reverse clutch via the low reverse solenoid. In second through fourth gears, the solenoid switch valve directs fluid to the converter clutch switch valve and the converter clutch regulator valve in the pump assembly. The valve body also contains accumulators, which provide gradual clutch pressure to cushion shifts, and check balls, which dictate the directional flow of hydraulic fluid. Coming up shortly, you'll see that the 45 RFE uses shift solenoids to route fluid through the valve body to the appropriate clutch circuit. Now let's take a closer look at the 45 RFE's clutches, starting from the front of the transmission and working our way toward the back. Located behind the fluid pump is the input clutch assembly, which consists of the underdrive, overdrive, and reverse clutches. Farther back in the transmission case are the fourth and second holding clutches. The low reverse holding clutch is near the rear of the transmission. The overrunning clutch, or freewheel, is used to improve shift quality. The overrunning clutch is employed during 1-2, 2-1, and 3-1 shifts. To achieve its different gear ratios, the 45 RFE applies different combinations of 2 clutches at a time. Let's take a look at which clutches are applied for each gear position. In park and neutral, only the low reverse clutch is applied. In reverse, the 3-to-1 gear ratio is obtained by applying the low reverse clutch and the reverse clutch. In first gear, the underdrive and low reverse clutches are applied, and the overrunning clutch is active. The low reverse clutch is released when the output shaft speed reaches approximately 150 RPM. In second gear, the underdrive clutch and second clutch are applied together. In third gear, the second clutch is released and the overdrive clutch is applied with the underdrive clutch. And in fourth gear, or overdrive, the overdrive and fourth clutches are used to obtain a final drive of 0.75 to 1. During certain kickdown shifts, the 2' gear is obtained by employing the underdrive and fourth clutches. When the gear selector is in manual low, the underdrive and low reverse clutches are applied. A chart of the clutches applied for each gear position is included in this month's reference book. The 45 RFE uses 3 planetary gear sets to derive its gear ratios. They are located behind the fourth clutch retainer. The use of 3 planetaries reduces noise, vibration, and harshness and allows for a deeper low gear ratio. We'll be covering the many electronic components found on the 45 RFE transmission in the next segment. Try answering another review question before we move on. Which of the following clutches are not part of the input clutch assembly? A, the reverse clutch. B, the low reverse clutch. C, the underdrive clutch. Or D, the overdrive clutch. Go ahead and stop the tape for a group discussion. The correct answer is B. The input clutch assembly consists of the underdrive, overdrive, and reverse clutches. The low reverse clutch is a holding clutch. Because the 45 RFE transmission is fully electronically controlled, you need to familiarize yourselves with these new electronic components and controls. The advantages of this electronic control include very consistent shift quality, with the driver feeling better shifts overall. Electronic control of things like shift points and line pressure can also help to improve durability of the transmission. Electronic control also facilitates the diagnosis of suspected transmission problems, with items like diagnostic trouble codes and clutch volume indexes to help you find and fix the problem quickly and efficiently. Let's start with the Transmission Control Module, or TCM, which is the brain of an electronic transmission, and go over all the electronic components used with the 45 RFE. The TCM is located under the hood and handles all of the transmission control that was previously the responsibility of the powertrain control module on rear-wheel drive trucks and Jeep vehicles. The TCM uses its inputs, such as sensors and switches, to determine the appropriate gear ratio and schedule shift points. The TCM uses outputs like shift solenoids to perform the actual shifts. The TCM also communicates with other control modules, such as the PCM, over the vehicle's PCI data bus. The TCM's electrical terminals mate to a 60-way connector, and the TCM is flash programmable. Now let's look at the TCM's direct inputs, that is, those that are hardwired directly to the TCM. The TCM receives power input from two sources: fused battery power and a fused ignition switch input. Of course, the TCM also has a ground to complete its power circuit. The input speed sensor reads input shaft speed off a tone wheel. The TCM compares this reading with that of the output speed sensor, which is also sensed from a tone wheel. This comparison provides the TCM with gear ratio information. The crankshaft position sensor supplies the TCM with engine RPM data that is critical to scheduling shift points. Besides the shift solenoids we mentioned earlier, the solenoid pack TRS assembly contains several different inputs. The transmission range sensor, or TRS, contains 5 switches that tell the TCM, through different combinations of switch states, what position the gear selector is in. The TRS also includes a backup lamp switch. The transmission temperature sensor, or TTS, is a thermistor that the TCM uses to monitor the temperature of the transmission fluid. The solenoid pack TRS assembly also houses 5 pressure switches that indicate to the TCM the presence of hydraulic pressure in each clutch circuit. These pressure switches are for the low reverse clutch, the underdrive and overdrive clutches, and the second and fourth clutches. Another direct input to the TCM is the line pressure sensor, which it uses to read main line pressure. Because the TCM uses throttle angle when scheduling shifts, the throttle position sensor is hardwired to the TCM. The overdrive off switch, which cancels overdrive operation, is also a direct TCM input. In addition to inputs wired directly to the TCM, there are other inputs that the TCM obtains from other control modules over the PCI data bus, which you would call indirect inputs. Keep in mind, though, that if the bus is down for some reason, the TCM won't be able to receive these inputs. Although the crank position sensor is a direct input, the TCM also gets an engine RPM reading over the bus. Another indirect input to the TCM is manifold pressure, as read from the MAP sensor. The TCM uses the manifold pressure reading as a factor in calculating torque and to prevent grade hunting. The TCM receives the target idle speed, which it compares to actual idle speed, over the PCI bus. The battery temperature sensor, which provides ambient temperature readings, is another input used by the TCM. The TCM uses the engine coolant temperature sensor reading to calculate transmission temperature if the TTS signal is out of range. The brake switch state is another indirect input. The TCM disengages the torque converter clutch when the brakes are applied. And because the TCM adjusts the transmission shift schedule when the vehicle speed control system is on, the speed control on-off switch state is also an indirect input to the TCM. Now that you've seen all the hardwired and indirect inputs that the TCM uses to decide when to shift gears,